On this next section, we're going to be looking at rational exponents, and that is when we're dealing with problems that we've already dealt with. Instead of having an integer exponent, we're going to have fractions. So for example, if we have things like x squared times x cubed, you recall that we add those up so we get 5. If I have x squared to the third, that gives me x to the sixth because we multiply those. And then if we have x to the negative 2, remember that it moves to the denominator. So if the negative's in the numerator, it moves to the denominator. If it's in the denominator, it moves to the numerator. So this is going to be very similar. So what is the value of 2 1/2? So I could plug that in. That really is the square root of 2. Notice with the square root, I'm just writing the 2 there for now, just because I want you to get used to me doing that when it is cube root, fourth root, and everything else. I don't have to write that. I could have just written it as the square root of 2 and it would have been fine. So this comes out to be about 1.14414. And so when we start looking at these values, that's the approximation if I'm doing it on a calculator. So now it says graph 2 to the x for each integer from -2 to x equals 5. So what we're going to do is we're going to move over and do that here, but instead of doing it on that sheet, I'm just going to go to Desmos. I'm going to log into desmos.com. Notice I'm already on here. I'm going to go to the graphing calculator. I'm going to go to y equals 2 to the x power. Notice it gives me this particular graph here. And then it says I want to be graphing it from -2 to, I believe, +5, if that's what it said. Let's go back and look at that. So +5. So if we're looking at this particular graph, here's -2, +5 is like right about here. We can see how it kind of goes up. And so what we're going to do is we're going to be able to graph it. This is what is known as an exponential function. You'll notice that it goes through a couple of important points. So number one is that it goes through 0, 1. And that's because 2 to the 0 is 1. And so I'll show you that in a little bit. You'll also notice that it, kind of goes through here too. So that is 2, 4. You'll notice it goes through 1, 2. And what I want you to recognize is 1, 2. And so if you use the x value of 1, notice up here, so remember that point 1, 2. If I plug in a 1 here for x, I'm going to get 2 to the first power, which is, of course, 2, so y equals 2. So we can go through and we can look at how to do that as well. So, of course, when x is 0, plug in a 0 here. Anything to the 0 power is always 1, so that's why we get the 1. If I come up here, you can see that at 2, so it is 4, so that means if I plug in x equals 2, 2 squared is equal to 4. So that's how I would look at that. So that's an accurate graph. You'll notice that as it starts going on the negative side of the x, that we hit this point right here. And this one I am going to show you. So at -2, it becomes 0.25. Keep that in mind. And at -1, if I can get there, come on, just a little bit more. Let's get that exactly right. At -1, it's 0.5. So if I go back over to my sheet there and just kind of point out some of the values that we came up with, remember that y equals 2 to the x. If I plug in a 0, I get 2 to the 0, which is 1. If I plug in a 1, I get 2 to the 1 is equal to 2. If I get a 2, 2 squared is equal to 4. We can keep going. So 3, 2 to the third is equal to 8. And you'll notice it's exponentially increasing. It's multiplying by 2 every single time we go up. But if we go negative, 2 to the -1, if you recall, is 1/2 to the first power, which is really 1/2. At -2, we have 2 to the -2, which is 1/2 squared, which is really 1/4. And if you remember on the graph, that was 0.25. So it's giving me the right information there. So now what it says in this problem is it says that we want to go and find some consecutive ones, but you'll notice the grade or the graph here, which is what we see on Desmos. Does it appear that 2 to the 1/2 is halfway in between the integers? So 2 to the 1/2. So when x is equal to 1/2, which is right here. That's when x is equal to 1/2. If we go up, you'll see that it's kind of located right about there. It's pretty close to 1.4, just a little bit above it. So just a little tiny bit above 1.4. So that's what we do to graph it. If you recall, when we used a calculator, when I wrote down the value, the answer is actually 1.414. So we can see that when x is 1/2, 2 to the 1/2 is about 1.4. More accurately, it's 1.414. So that's what we're looking for when we're looking at these different values. Now, if we want to do 2 to the 1/3, when x is equal to 1/3, which is about 0.33, this is 0.5, here is 0.3. So 0.33 might be right around this value, so right around here. So it looks like it's pretty close to 1.25, kind of halfway in there. And now if we go over to a calculator and try to figure out what that value is, I can go through and I can do a calculator, run the value, and see what it is. And let's see if I can figure out how to get that value here. So 2 to the 1 divided by 3, and notice 1.259, and so that is approximately about what the answer I got. So 1.26. So I'm getting good accurate values when I'm looking at the graphs, and we can see what those different values are in there. So the next part of this, we'll start getting into understanding how to deal with these functions.